Hi everyone, my name is Bhavya Varma. I am assistant professor from Mlritm college. I belongs to the department Computer Science and Engineering. So today I am going to discuss about the topic that is OS, scheduling algorithms, operating system scheduling algorithms. So I'm going to discuss about why we need to go for scheduling algorithms and the scheduling criteria and the concepts, and also going to discuss about the algorithms like FCFS, that is first come first serve. So there are four types of scheduling algorithms. Today I'm going to focus on first come first serve scheduling algorithm. So operating system scheduling is the process of determining which process will run at any given time. So there are multiple processes. For example, if you imagine a movie theater where you're going to try to book a ticket. So now if it is an offline concept, then you have to go to the counter and you are going to stand in a queue and then you are going to book a ticket. For example, if there is no queue or no counter, no proper process, so multiple people will try to access the counter place. There would be so much of messy, or there will be going so many disturbances if there is no such a process of maintaining a queue. If there is no process, if they're not maintaining this queue to allow one by one, and if this system is not being followed, then the people cannot access, then they cannot get in a then they cannot book the ticket in a proper way. So if there is no proper way, there will be so many disturbances. So as the for that situation, who came first, they are going to book a ticket, they are going to be in the queue. So this is some process which is followed because so many people will come here. Also, while we are executing the process, while there is a task, that task is divided into the process, and these multiple processes are being executed in our system. So OS, we already know, it is an interface. So it is an interface between a system and us. For example, if you're trying to start, or if you're trying to work with a system, you're going to start, how do you going to work with that system? Like if I are going to use a computer, we need to switch on the computer, right? So while you're switching on the computer, here the switch is an OS. Between user and the computer, the switch is an OS. In the same how here, to work with our system, internal system, we need this OS, which acts as an interface. So by having all these knowledge, today I'm going to discuss about scheduling algorithm. So the scheduler manages the process in a system to ensure efficient CPU utilization. So why we need this? So as I said earlier about the system which is followed in the booking counter, that is a queue system. If the system is not there, if that system is not existed, so how many persons can buy a ticket properly? And might be the late person can get the ticket in however way, whatever the way. If not, if the ticket giving person who is working there, he might only give the tickets to his friends. So it will be like that. No criteria is followed there. So such that what happens is the persons who are coming, they cannot get the ticket. So such that they are following a process called a queue system. Here also there are multiple processes. So we are trying to maintain the CPU utilization well, to increase the efficiency of the system, and also to decrease the response time and to decrease the waiting time. We are going to use these scheduling algorithms. Okay, scheduling algorithms are used to allocate resources to processes based on their arrival time. So resources means what? It might be a printer, it might be a scanner. So for each process, here scheduling algorithm coming. So P1, P2, P3, there are some such following process, etc. So they need these resources. One process want to print, one process want to scan, one process want to listen some music, etc. So there are multiple resources to be used by this process. So that is what to maintain for these purposes, to maintain or overcome these ambiguities and the problems which are arising, okay, where the efficiency is getting badly affected. We are going to use these scheduling algorithms for the processes. There are two types of scheduling algorithms. Actually, scheduling algorithms are of two types: preemptive scheduling and non-preemptive scheduling. So, preemptive scheduling, what it does, it allows running process to be interrupted by a high priority process. So what is preemption? For example, P1 is in a queue, here. Okay. Now, P2 is in the queue and P3, for example, these are in the queue. So, for example, they are at a medical shop. Okay. P1 want some tablets and P2 want some emergency injection. Okay. Some P3 want some tablets. Okay. So now, as we are following, as if we follow this to discriminate this preemption and to discriminate non-preemption, okay, non-preemption and preemption. So you can see the concept of non-preemption. First, I am going to discuss about the concept of non-preemption, that is P1, P2, P3 are in a queue. For example, queue system is as who comes first, they will be allocated and then they will be terminated. That process is getting terminated. So by this time you should have an idea regarding ready, running, waiting, termination, states, exit. So these are all the states of the process. So as we all know the idea regarding these states, so we are going to use this concept to understand. So now preemption is nothing but non-preemption. Under the non-preemption concept, P1 has taken the tablets, he have paid the bill, then P2 has come. Okay, so you want the emergency. So if this non-preemption means, what this non-preemption is telling means there will be no suspension. Preemption means all the time we say preemption is nothing but it is suspension. Okay, so suspending the process for a while. Non-preemption is nothing but where there is no suspension. So as I said in the non-preemption, what happens is P1, P2, P3, they are in how order they have come, they will be executing. That means he is going to purchase, first P1 is in the line, so he is going to purchase his own tablets, and P2 is in the line, he is going to purchase his injection, and P3 again he wants some tablets. So here, if it is non-preemption, the concept will be one by one without any suspension. P1 will not be suspended, okay, because of some reason. So when you come to the preemptive, if there is one case in the same scenario, P2 is for what it has. The purpose of P2 is what it want emergency injection. If that is not taken and given to a patient within 10 minutes, it would be a risk for the patient. For example, this is the case. Okay, we want an emergency injection. So now that emergency injection should be given within 10 minutes to a patient. Then he has to come within 10 minutes. So there is some constraint, emergency situation. In that time, if it is non-preemptive model, then there is a problem. So that's why there are two types, preemption and non-preemption, where here preemption plays a key role. That is where P2 wants an emergency injections, right? So according to his prescription or according to his emergency situation, now what happens, P1 will be suspended. That means he is going to be aside for a while, and P2 will be first given opportunity. Okay, now P1 is in the first position, but he has to wait till P2 is taken his kit and emergency kit, and he should leave from there. Then again P1, P2 will be executing. So you should get a proper idea here what is preemption and what is non-preemption. So there are two types of scheduling. What are those? Preemption and non-preemption. Preemption means suspending for a time, for a while. So as we have seen in the example scenario here, so if there is an emergency problem, so if a person who is getting into the ICU, or he wants to admit immediately, which is an emergency, if there is prior some other person before admitting the at the reception, then this, if non-preemption model is followed, a it is a dangerous scenario, because we can't make a person, he or she might die if we go in the sequence, or if we go in a non-preemptive model. So basically this is the difference between the preemption and non-preemption. Preemption means suspending, non-preemption is where you won't suspend. So according to the situations, for these type of situations, for such type of scenarios, we are having following scheduling algorithms. We are going to discuss the scheduling algorithm, that is FCFS, and SJF, and priority scheduling, round robin scheduling. So these are the four scheduling algorithms. So today I am going to mainly focus on FCFS. So before that, see here, what is process scheduler? Process scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithm. Okay, whatever the particular scheduling algorithm, it might be followed. Based upon that, this process scheduler will schedule to different processes. So those processes should be followed one of the scheduling algorithm. So that will be maintained by this process schedule. Okay, so as we are having this following, so these following scheduling algorithms will be having two types of scheduling algorithms, that is preemptive and non-preemptive. Okay, so FCFS, always it is non-preemptive only. Okay, we don't have any preemption model using this FCFS scheduling algorithm. And where SJF has two, non-preemption and preemption. So if it is non-preemption, we say it is SJF. If it is a preemption, we can say SJF with preemption, or shortest remaining time first, shortest remaining time first. Okay, slowly while we are discussing one by one, you can come to know what are all these. Next, we have priority scheduling. Okay, priority itself based on the priorities. The shortest job itself says based on the shortest burst times, we are going to execute the processes. So priority scheduling is also having two types, non-preemption and preemption. So both are there for priority. Again, when you go for round robin, it is following a concept called round robin. So where each round robin has some scheduling concept. So it is also having only one model, that is round robin, where it is also it's not like a non-preemptive and preemptive. So its scenario is little different. Okay, so we are going to discuss each in detail. So let us discuss the first scheduling algorithm, first come first serve. Okay, so first come first serve, you can see in the you can see here, that is FCFS, first come first serve. Term itself says that is it is following some queue concept. Okay, processes are executed in the order they have arrived. They have arrived in the ready queue. Okay, we know ready, running, waiting, termination, exit states. Okay, new, ready, running, waiting, termination. These are the states of the processes, right? So here the process which are ready in the ready queue, that are ready to execute, are in the ready queue. So these processes are now executed under a scheduling algorithm model, that is FCFS. Okay, using FCFS scheduling algorithm, the processes are now discussed how they are executed. So the process when are in the ready queue, what is the scheduling algorithm is to be followed will be given by the scheduler, process scheduler, and that concept is followed while executing these processes. So now we are going to discuss about FCFS. So FCFS is always non-preemptive algorithm. So you know what is non-preemptive? Oh, there is no suspension. Process queue. Okay, there is a queue, right? First come, first serve, okay, which has been come in a order. How it is arrived, in such way it is executed. So process queue to arrive gets executed first, which has come first, that is executed. Okay, so before knowing that, we have to have to know about concept called burst time, arrival time. Okay, so arrival time means nothing but 0, 1, 2, 3. For example, P1 is a process which has arrived at 0, and P2 is a process which is arrived at the time of 1. So like that, that is arrival time, where the process have arrived, when the process have arrived is shown in the arrival times. Burst time is, for example, I say the burst times 1, 2, 3. Process P1 is having the burst time 1, so it takes 1 unit. For understanding purpose, 1 unit of time is required to complete the P1 process, to execute the whole task or whole subtask of a P1 process. And P2 needs 2 units, and P3 needs some 3, and P4 needs some 5. Okay, don't think that I'm writing the sequence numbers. So these burst times, arrival times are given to you, and then based on that you are going to use what algorithm should be implemented, and based on that concept and the algorithm condition, you have to execute the whole processes. So, and burst time, arrival time, and you can see here turnaround time and waiting time. Okay, while we are discussing the example, you can clearly notice what is what, and you will clearly understand how can we know all how it is executed based on one particular algorithm, and how you can conclude it. Okay, the average waiting time and average turnaround time matters here, where always we are going to aim to decrease the waiting time, okay, how much fast we are, in a fraction of seconds we can give the response time. That is the goal here we are trying. Okay, we are trying to reduce the response time of the system. Okay, that is why we are going to discuss all these scheduling algorithms. So turnaround time is nothing but, see, there is a formula called completion time minus arrival time, and waiting times formula is turnaround time minus burst time. As now you got an idea what is arrival time, at what time the process have arrived, that time, that times are called as arrival times, and burst time is nothing but in how much time, how much unit of time it is the particular process are will be executed, that particular process will be executed. So 1, 3, 5, it may be anything. So that is what. Okay, so now let's go to the example to deeply dive about this concept. Okay, now there is the list of the process and given arrival times and given burst times. Okay, so here you can see all the arrival times of 0. So it's not mandatory that arrival times should be different, and it's not mandatory that arrival times will be 0. Okay, zeros, if it is the condition that all the arrival times of 0, then you say that all the process, what are the process we have, P1, P2, P3 and P4, these are in the ready state, already in the ready queue. They are, that means ready queue, if they are ready, their process are ready now for execution. All the process has come at one time only, has come. All the processes has come at once. Okay, so for example, if there is a function, so all the guests could not come at a one particular time, but if it is a movie, almost all will try to come at that time of point, right? There is a difference. So here the arrival time of these processes, what according to the given example, they have come at once, that is 0. Okay, 0 is the arrival time, and given burst time, see, P1 is executed, like P1's burst time is 5, so it will be completed by the time 5 units of consuming of 5 units of time. Okay, and P2 will be completed by consuming 3 units of time, and P3 is completed by the 2 units of time. This is how This is how you should understand. Okay, now this example we are going to discuss with different arrival times also. First, let us see with the same arrival times, that is 0, where that means 0 means all the processes are ready. Okay, if it is all arrived at 1, if you say it is not 0, all are 1, so that means all has come at the point of time 1. All the processes are ready at the point of time 1. Okay, so now at the point of time 1, these are in the ready state. That means ready to execute. Now, according to our example, so now all the processes are ready. So now we can start executing this process based on this FCFS. See, the scheduling algorithm, if all the processes have 0, all the processes arrived at the time what? 0. The scheduling will still be based on FCFS. Since there are no arrival time differences, the process will be executed in the order they appear. The condition here, since all has come at the same time, that is all has come at the time 0, so all are ready. So in which order they have come, that order is taken to execute. In which order they have come? P1, P2, P3, P4. So now in that way, it is in that order it will be executing. Clear? Now, so while you are executing, we need to take a Gantt chart. Okay, Gantt chart is nothing but a horizontal line where it is a graphical representation of the process execution. Graphical representation. So we are going to graphically represent that in a chart. It has a horizontal line where the process in which order it is being executed. Okay, so that's why we are going to based on Gantt chart. So completely basing on this Gantt chart, you can tell which process is how you are getting scheduled and how you are going to, which algorithm is scheduled, and based on that, the condition of that particular scheduling algorithm, we are going to execute. And for that process order, which is first executed and which is next executed and following process are executed, to know this scenario, we are going to draw this Gantt chart, which is a graphical representation. Okay, in FCFS, first step 1 is creating a Gantt chart. In FCFS, process execute in the order of their arrival. Okay, in the order of their arrival, with each process running to the completion before the next start. So before the next process starts, we are going to running to the completion before the next process starts. Here, how it would look like. So how our process has come here? P1, P2, P3, P4. In the order they have come P1, P2, P3 and P4. So why we are taking in this order? As all the arrival times are 0. That means all the processes are ready. So now for FCFS, what we say? First come, first serve. So what is the order here? First P1 has come. So it is taken into the execution. It is taken to the CPU and it is executed. And next which has come? P2, P3, P4. Okay. Now I will draw a ready queue here. So that is P1, P2, P3, P4. For me, as I said here, P1, P2, P3, P4. 4 are ready in the ready queue because all has come at the point of 0. Okay. By the time of 0, here all the process has come. See, always for understanding purpose and for the nature. So I just draw this Gantt chart assuming from 0. The time is started from the Gantt chart, that is 0. Okay. So remember that it is started at the point of 0. So now basically, so if I say these processes are available at what time? According to our example at 0, right? By the time of 0, all process has come. For example, if I say the arrival times here is 1. The arrival time is 1. That means, so let us see. Here it is arrival times are 1. Okay. Now how can we go through this Gantt chart? So this Gantt chart is drawn at the point started from the 0 only. Okay. So at what time the process have arrived into the ready queue? At the point of 1. So 0 to 1. The CPU is idle. The CPU is idle. Okay. Clear? So if I say the process has come at 0, then you can start with the order. P1 has come. Okay. So if it is 0, P1 will be coming into the Gantt chart. So P1 will be coming for the execution. That is P1. What is the burst time of P1? 5. That's why we are going to take here 5. Next, P2. So till the concept of this FCFS is P1 will be is in the order. So it should complete its execution and it should leave. It should be terminated. That means 5 units of burst time. It is done with its task and it will be terminated. Next, which comes from the ready queue, P2 will be coming. So P2 is taken. P2 has come at what time? At 5. Okay. Because till 5, the P1 process is being executed. Now, at point of 5, P2 is in the next, in the order which is there, which is the next to the P1, P2 is there. So it comes at point of 5. So what is the burst time of P2? 3. So now 5 plus 3. Okay, it started at 5 and it requires 3 units of time. 5 plus 3, 8. Okay. Now, what is the burst time of P3? It is 2. So P2 is also done. P1, P2 done. P2 is also going out and now P3 has come into the CPU. That means in the Gantt chart. Okay, what is the burst time of P2? P2 burst time is, P3 burst time is 2. Right. P3's burst time is 2. So here P3 8 plus 2, that is 10. So it started at point of 8 and completed at point of 10. So what is the burst time of P4? 4. Yes. So now what is the burst time of P4? 4. So now 10 plus 4 is 14. So it has come at the point of time 10, and then what is the burst time of it? It is 4 units and that is done. 10 plus 4, total 14. Clear? So now P4 is also done. So in which order they have arrived? In that order only they are executed. But at what time they have arrived is 0. If they arrived in the same example, if they arrived, for example, for the same example, if all the process P1, P2, P3, P4 have arrived, that is the arrival time is 1, 1, 1 and the burst time will take as the same 5, 3, 2, 4. So 5, 3, 2, 4. Okay, because the Gantt chart varies now. Okay, now what I said, all the processes are available at which point? 1. That means not at 0. These are now have come at point of time call, that is 1. So now let us draw a Gantt chart. So this is our Gantt chart and this is our ready queue. Okay, all the processes are arrived by the time 1. All the processes what are there are ready, right? They are ready at which time? At 1. So always I start my Gantt chart from the point of time of 0. So now we started. So I'll see, is any process available at 0? No. So I'll go with 1 unit gap because for each unit I'm going to check. So now 0 to 1 there is no process has arrived. So it is idle. CPU is idle here. CPU is idle. Okay. So now at the point of 1 all the process has come. So in which order they have come, that order we are going to execute. P1. What is the burst time of P1? 5. So we'll do 1 plus 5. At which point it has come, arrived? At point of 1. Okay, as you have to take in a order. So P1 at point of 1 it has arrived and its burst time is 5. 1 plus 5, 6. After P1 is executed, we need to take which process? P2. So now P2 will be coming into the queue. So what is the burst time of P2? That is 3. That is 6 plus 3. That is 9. Right. So now next which process has come? P3. What is the burst time? It is 2. So 9 plus 2 is 11. 9 plus 2, 11. It is taking 2 units of burst time, right? So that's why we are going to add 2. And next last process is P4. Okay, P4, uh, P4 burst time is 4. That means 11 plus 4. 11 plus 4 is 15, right? If it is the case, they have arrived at the same time, that is 1 only, but all have arrived at one point of time, that is 1. But before 1, we start always the gun chart from 0 for understanding and for clarity purpose, as it starts from 0. Initially, we consider 0. So, from 0 to 1, the CPU is idle. If we start executing at that point of time, we are considering that as 0, and at the point of arrival time, that is 0, no process has arrived. So that's why we are going to the next unit, that is 1. So we are going to check at the time of 1 if any process has come. Yes, here for our example purpose, at the point of 1 there are 4 processes available for me. Okay, so 4 are in ready queue. Now these 4 should be executed. So in this way we are going to execute. Clear? So now we are going to with the same example. Let us go as earlier example where the processes are ready in the ready queue at the, that is arrival times are 0. Now we got a Gantt chart 0. So P1 has come here at the point of time 0 and it has completed by the time of 5, and P2 has come at 5 and it is completed by the point of time 8, and P3 has come by 8, arrived at 8 and it is completed by 10. And next it has entered, executed at the time of 10, P4, that is P4 is executed at the time of 10 and it is completed by the time of 14. Next, now for each process we are going to find out, we are going to calculate the completion time. We are going to calculate the completion time. So the completion time is which a process finishes executing. Which a process finishes executing. So at what time the P1 has completed, finished its time? So it's a P1 completion time, 5. And what is the completion time of P2? 8. And what is the completion time of P3? 10. And what is the completion time of P4? 14. So it finishes, P1 finishes at time 5. That means it started at time 0 and runs for 5 units. Running time runs for 5 units. That means it is a given burst time. It runs for 5 units of time. And P2 finishes at 8. That is, it started at 5 and it is completing, its burst time is 3. That means it runs for 3 units of time. Okay, so that 5 plus 3 is 8. Clear? So step 1, we create the Gantt chart, and after that we are going to find out the completion time, and going to the next step we are going to calculate the waiting time. Okay, so now we are going to calculate the waiting time. Clear? So P1 arrival times, P1, P2, 0, and given question. Okay, given burst times are taken, given arrival time should be noted here. And what is the starting time? It entered into the Gantt chart. P1, 0, P2's 5, 8 and 10. Okay, you can see the Gantt chart here. So P1 has started, start time of P1 is 0. Okay, P1 start time is 0, P2 start time is what? 5 ST. Okay, P3 start time is what? 8, and P4 start time is what? 10. Right, these are the starting times. So that's what we noted, 0, 5, 8, 10. And now at what time they have completed? We already know the list, 5, 8, 10, 14. Okay, 5, 8, 10, 14. Now we have to calculate the waiting time. Okay, the waiting time. So now see here, we already seen here waiting time and the turnaround times to be calculated. So now waiting time is, so here you can see the starting for process 0 minus 0, that is what? Waiting time of process 1 is 0. And next 0 starting time and arrival time. Next P2. The starting time of P2 is what? 5, and its arrival time is what? 0, that is 5. So starting time minus arrival time. And now you can see P3 where it has been started. It is started at the point of 8. 8 minus 0, that is 8 minus 0, that is 8. And next P4, it is started at the point of time 10 and its arrival time is 0. Okay, starting time minus arrival time, or you can say turnaround time minus arrival time as here. Okay, turnaround time minus burst time, or starting time minus arrival time. So you can calculate the waiting time in this way. Okay, now so all the waiting times are calculated. So what are the waiting times? 0, 5, 8, 10, right? So now we are going to take this. So we know the starting time, we know the completion time, we know the waiting time. Okay, now let's calculate turnaround time. Clear? Okay, turnaround time. Okay, the total time of the process that has been spent. See, the total time of a process that spends from arrival to the completion. So you say for each process P1, it has arrived at 0. It is completed at what time? P1 has started at 0. It has completed at point of 5. So here turnaround time means whole time, starting to ending of each process execution is said to be as turnaround time. So turnaround time, here you can say completion time minus arrival time. So let us see now. We already have the calculation here. We have already calculated the completion time. Completion time minus arrival times. Okay. So now 5 minus 0. What is the P1's completion time? 5. And what is the P1's arrival time? 0. That means 5. And P2, what is the completion time of P2? 8 minus, and it's what is the arrival time of P2 is 0, 8. So right here it is missing. So 5, 8, 10, 14. 5, 8, 10, 14. So we are going to put in a table process, arrival time, burst time, and you are going to include starting time, completion time, turnaround time, and waiting time. Clear? 5, 8, 10, 14. See here the completion time. See, you can see in the table completion time is how much? 5, 8, 10, 14. And turnaround time 5, 8, 10, 14. Both are same. So that means it is non-preemptive model. Okay. So that is what we can also conclude. So both are same. It is non-preemptive model. When these times, when the turnaround time and here the completion time are same. Okay, so now you are going to calculate the average waiting time and the average turnaround time. So average waiting time, we already know what are the waiting times here. 0, 5, 8, 10. 0 plus 5 plus 8 plus 10. And how many processes we have total? 4. So what are all the waiting times we got for each process? P1's waiting time, P2's waiting time, P3's waiting time, P4 divided by how many processes we have? 4 processes. So total number of processes. So the formula we already know. We know the average formula, right? So total each and every process waiting times and divided by total number of processes is going to be giving the average waiting time. And turnaround time is also same. P1's turnaround time, P2, P3, all the 4 processes turnaround times and then divided by total number of processes. So you are going to get average turnaround time, that is 9.25. And this is how the example with where the process has come at once. At one point of time all the processes have come. So they are ready in the ready queue at that particular time. So according to our example, they are ready by the time 0. So you are going to calculate this average waiting time, turnaround time. You are going to check the efficiency here in this way. And next, let us discuss example 2, that is with different arrival time. See here, as we discussed about 0, okay, or 1 also we discussed, because where all the process come at one point of time. Now here the processor come at different times. So P1 is ready at the point of 0, P2 is ready at the point of 1, P3 is ready at the point of 2, and P4 is ready at the point of 3. So now let us see. Now, so already we know how you are going to take. So as all the arrival times of 0 are 0, in the early example you have taken the order of the process. Okay, as you can see here, all are not ready in the ready queue. That is, P1 is ready at the point of 0. Okay, P2 is ready at the point of 1. P3 is ready at the point of 2, and P4 is ready at the point of 3. So now there are different arrival times. In earlier example, all are ready at time of 0 itself. So all have come into the ready queue. So now when you start the Gantt chart, you start with what? Start at point of 0. So at 0, which process is available for me? P1, because P1's arrival time is 0 and its burst time is 5. Its burst time is 5, right? So P1 is arrival time is 0 and burst time is 5. Still any other process is available at the time of 0? No. No process has come. Only P1 has come at the time of 0. That means now P1 is ready. As we started our Gantt chart, as we started our execution CPU, the Gantt chart we are going to represent in the graphical representation using this Gantt chart. So P1, we assume it starts from 0. At point of 0, what process is available for me in the ready queue? That is P1 only. Okay. Now what is the burst time of P1? 5. So now what I do? 0. It has come at 0 and the burst time of this P1 is 5. So 0 plus 5. So it is completed at point of 5. Okay. Now, so by the time of 5, so till 5, P1 is getting executing, right? So till 5, this P1, till the P1 is completing its execution, at the time, by the time 5, okay, before, like by the time the P1 process is being executed, is executed, you can see the arrival times. What are the arrival times for P2? 1, 2, 3. So now we can say, by completing the first process, by the time of 5, all the processes are ready, right? All the processes will come into the ready queue. That is P2, P3, P4. Now all the processes are ready. Okay, what is the sequence here? See, you have to remember 0 to 5. It is being executed. That is P1 is being executed, right? So P1, when the P1 has come, it has come at 0. P2 has come at 1. P3 has with 2. P4 is with 3. These are the arrival times, right? So it has come first at the point of 0. So it is getting executed here. That is with the 5 units of burst time. So 0 plus 5, it is executed 0 to 5, right? Now by the time of 5, this P2, P3 have come at what time they have arrived? At 1, 2, 3. That means before 5, right? Before 5 itself they have arrived. That means they are now taken into the ready queue. Okay. So they are taken into the ready queue. So P2, P3, P4 are in the ready queue by the completion, in the time of the completion of P1. Now these are in the ready queue. So as these are in the ready queue, that is P2, P3, P4 are in the ready queue. So now all are in ready queue. Now which process has to be taken at 5? At the point of time 5, now P2, P3, P4 are in the ready queue. Now which process has to be taken here? That is, you can check with the arrival times. What are the arrival times here? 1, 2, 3. They are anyhow they are ready. Okay, they are in the ready queue because by the time of the completion of P1 process execution itself, they have arrived. So P1, P2, P3. Now, in what order you have to take? As in the early example, you have taken the process order. Okay, the order of the process P1, P2, P3. Right. In that order, you have executed. Now, here P2, P3, P4 are in the ready queue, and now which process has to be taken? So as the scheduling algorithm is itself FCFS. Okay, you have to take in which order. Now we have to check with our arrival time. Now you have to check with our arrival times. So 1, 2, 3. So you can see the sequence 1, 2, 3. So 1, right? First, this process, this arrival time is in the first. So which process has come at this point? 1, P2. So P2 is taken. Okay, what is the burst time of P2? 3. 5 plus 3. Clear? Now, this is also executed, and now P3. P3 and P4 are in the ready queue. Now, which process has to be taken here? Has to be taken into the Gantt chart? P3 and P4. So, which is the first one you have to take? Here, check with the arrival time. 2, 3. 2 is first, right? So, 2. The process is P3. So, P3 is taken. So, 8 plus 2. And the last we have P4 with the burst time, that is 3. With the arrival time, that is 3. And it is the last one. P4 is taken. And 10 plus 4 is clear. So, if the arrival times are 0, all the processes are ready, and in the order of the process numbers you are taken. Okay. So, when you come to the different arrival times, you have to check with the arrival times. The sequence of arrival times are taken, and according to that you are going to execute with their own burst times. By adding their own burst times, you are going to execute. Now check with the starting times and completion times. P1 has starting time is 0. Starting times, okay, P1 is 0 and P2 is 5, P3 is 8, P3 is 8, P4 is 10, and completion time of this starting time, completion time, and P1 has completed at 0.5, 8, 10, 14. Okay, now let us calculate turnaround time and waiting time, right? So you already know how should we calculate the turnaround time and waiting time. So here, so waiting time is how? Starting time minus arrival time, and turnaround time is how? Completion time minus the burst time. So here, as in the previous example, we discussed the turnaround time and waiting time. So here we are going to calculate the completion time. So we have completed the completion time. Here is 5, 8, 10, 14. So 5, 8, 10, 14. Right. Next, turnaround time. So how can we calculate the turnaround time? Completion time minus arrival time. So that is 5 minus 0, 5, 8 minus 1, 7, and respectively Accordingly, you have to follow this completion time minus arrival time. And waiting time will be calculated. So waiting time can be calculated through turnaround time. Okay, that is turnaround time minus burst time. Okay, so turnaround time is 5, that is 5. And what is the burst time? 5 minus 5. And what is the turnaround time? 7. 7 minus 3, right? So in this way, you are going to calculate the waiting times and the turnaround times. And then you calculate the average. So what are the waiting time of each and every process? 40, 4, 6, 7 divided by number of processes are 4. So 4.25, and turnaround time, each process is turnaround time, and then divided by 4, that is 7.75. So this is how we are going to calculate. Okay, so FCFS characteristics. So here the advantages, it is very simple and easy to implement, and no need of any complex calculations. As you remember, as we remember turnaround time and waiting time. So the formula, that is how we can calculate the FCFS. Simple. There is no conditions while you are executing. So whatever the process, in which order the process has come, you are going to execute in the same way, or you are going to check with the arrival times, and we, according to the ascending order of the arrival times, based on that you are going to take the sequence of the process and you are going to execute. Okay, so there is no complexity here. Disadvantage is convoy effect. Convoy effect means long process can be delayed. A long process can delay the shorter processes. Poor average waiting time. So the average waiting time is very like it's more when compared to the other algorithm. So here convoy effect is the major disadvantage. Okay, convoy effect. So before see, convoy effect means nothing but what it is mean by where longer process will be delaying the shorter process, right? For example, there is a supermarket. Okay, there is a supermarket. There is a person one. Okay, person one is with 50 items. Okay, person is with billing counter. This is a billing counter. Okay, one person will be doing the billing. P1. This is a queue. Person 1, person 2 is holding with 2 items. Person 3 is holding with some 4 items. Okay, let us consider this example. Okay, person 1 is having how many items? 50 items they should be given. For example, you are seeing in DMart or some other Vijayata supermarket, Ratnadip. So there are many, right? In which queue they will be following, right? Queue system. Here, the queue system is fine. But in some cases, due to the person 1, the person 2 is the next person is being delayed, because as here, see this in such scenarios, in which scenarios, see here, in this type of scenario where person 1 is having some 50 items to be built and person 2 is having only 2 items, person 3 is having 4. Okay, so till the 50 items are getting built, till this billing is completed, that person's one billing is completed, the next person should wait till how much time? 50. Let us consider for each item 1 unit of time, which should wait for 50 units. He's having only 2. Okay, so for that 2 items, for that purpose he is made to wait for longer time. Please, we have to wait till 50 units. By the time of 52 units, he can complete his billing. So here what happens is, because of person P1, the person P2 is getting delayed. Okay, if there is some condition like shortest job first, so the person P2 will be taken first, he will be executed. So why this is called as convoy, this convoy effect? What it is concluding is, till the person 1 completing its billing, the person 2 is getting waited, right? So compared to the waiting time, you can check the waiting time. So how much time person 2 is waiting for 50 units of time? Okay, 50 items. For each item I'm taking, considering for understanding purpose, we are taking each unit 50 units, right? For example, P2 has to wait for 50 units, right? If suppose P1 is holded and P2 is executed first. P2 is waiting how much time? If I say P2 can be built first because it is having only 2 items. Okay, P1 is with 50 items, rather P2 waiting, we are executing this P2. Then, so at when this P2 is given priority, because it is having less items, only 2 units of time it requires, so it will be completing. So how much time P2 is waiting? 2 units of time. So compare P1 is waiting and P2 is waiting. Right. So this P1 process is making the P2 process to wait for a longer. Right. If these 2 items will be done, then he can send that person. Okay, he can complete its billing. So for the person who is waiting for 50 units or who is with so many items, he can wait for 2 units of time. Right. That is okay. So this is called as a convoy effect, which is causing a delay to the shorter processes. Okay, which is calling to the delay for the shorter process. So this is all about our FCFS scheduling algorithm, and we also discussed about preemption, non-preemption. So in the further classes, I'm going to discuss about the coming scheduling algorithms. Thank you.